Hi everyone, this is Vijay Chandu from CSC AML branch. Today I am going to explain about double hashing sort algorithm. Introduction. When we start a huge amount of data using an algorithm with complexity equals order of n square, like insertion sort on a home computer. For example, it takes roughly 317 years. In contrast, as displayed in this table 1, investing in hardware versus ideas. Using a supercomputer instead takes 1 week. However, investing in ideas by using another algorithm with complexity equals to order of n log n, such as quicksort, consumes less computational time and takes only 12 minutes on a home computer. This presentation introduces a sorting algorithm that uses a double hashing methodology in which the first hashing collects statistics about element distribution and the second maps between elements of the array and the indexes based on the knowledge collected during the first step. Especially, we analyze the proposed algorithms, time complexity mathematically and empirically. The proposed algorithm has three phases. Phase 1, first hashing. Hashing is the process of obtaining in an index by chopping up the key and mixing it up in various ways that will be uniformly distributed over a range of indexes. In the first hashing, the algorithm collects statistics about the distribution of elements in the array. It then divides the array into blocks and calculates the number of items in each block. During this phase, the algorithm creates counter array. The following equation shows how the array is partitioned into 10 blocks. Here is the equation. The algorithm performs the following equation on each element of the array to calculate the elements block and increment. Phase 2, second hashing. The second hashing doesn't work blindly, rather it uses the statistics collected during the first hashing. Especially the algorithm gets each element specified block and calculates its maximum and minimum using the equation, using the formula given. It then maps the element to virtual indexes and its specified block using the following equations. So if the element is E, the specified block is B and counter array B equal to 5. The algorithm maps E to its virtual index within 5 elements. At the end of this step, the algorithm gets an array of indexes. However, some of these indexes are integers and some are floating point. Phase 3, sorting elements in each slot. In the third phase, the algorithm contains a set of virtual indexes at each block and partitions the indexes to slots, which each slot containing one or more indexes that share integer parts. Each slot is divided into two arrays. Equal array contains the integer index and its repeated values, and the greater index contains the float indexes. It's the only array that should be sorted. The algorithm uses quicksort to sort greater array. Figure 1 shows the floating chart of the double hashing sort algorithm. Here is the here is the flow chart. Analysis of double hashing algorithm. As mentioned earlier, the algorithm is executed in two phases. Phase 1 is for loop. Phase 1 is for loop the from I equal to 0 to n minus 1, where the basic operation is the first hashing. The first phase calculates the count of elements in each block by receiving the specified block for each element. I am incrementing it by 1. In this step, the complexity is Tn. The basic operation in phase 2 involves hashing for each element in the block. In this step, the complexity is Tn equal to sigma equal to 1. The total complexity is Tn. The best case exists when all the elements in the array are well distributed and one of two values size of array or m maximum in array is small. For example, n equal to 10 and m equal to 0, 100. The complexity is the best case version of the third phase. In Tn equal to order of n plus order of n plus order of n equal to 3 order of n and tends to be Tn equal to order of n. The worst case exists when n is large and m is small, which happens with algorithm takes more computational time. In this case, greater array contains a large number of elements The complexity of the worst case is Tn equal to order of n plus order of n plus order of p into m log m, and tends to be T of n equals to order of n plus order of n plus order of x log m, where p is the number of slots that contains greater array, m is the length of greater array, and x very less than n. The complexity of average case is Tn equal to order of n plus order of n plus order of p into m log m, and tends to be Tn equal to order of n plus order of n plus order of x log m, where p is the number of slots that contains greater array and m is the length of greater array and x is very less than n. Conclusion. Ultimately, double hashing sort is a stable algorithm. If the array contains two elements with equal keys, they exist in same block. Their mapping values are equal. They are inserted in the same slot in equal array, and the algorithm places them in the same order in sorted output as they appear in the input array. Thank you.